how do we know what we know about hominin evolution? So what I want to do today is take you through one approach we've done here at BYU in deciphering the phylogeny, or the evolutionary relationships among hominins, because this shows how this very fascinating group of organisms has changed over time. Now, in studying hominin evolution, most of the evidence that we have comes from bones associated primarily with the skull. And so we have fragments of the cranium, we have fragments of jaws, and we have teeth. And the reason why we have these fragments is because they preserve so well. But there are some really special cases where we have found nearly complete skeletons of these organisms. And you can see three of them in front of you right here. The first one is Australopithecus afarensis, and this is Lucy, the Lucy that you've heard of. And you can see, first of all, that Lucy did not stand very tall. She was shorter than 5 feet high. And she has some very interesting features of the skull. You'll notice that the face is projected out a little bit more than what we have in our own species. The arms on Lucy were quite long. So she could take her arms, and when she was standing upright, the length of those arms could come down and nearly cover the kneecaps. And what we know about Lucy is that she was bipedal. She had the ability to walk upright, and that's due to features we see in the femur and in the shape of the pelvis. So this is Lucy, and Lucy is at about 3.2 million years ago. The next most complete fossil we have is this one here called Turconaboy, or Homo ergaster. Now, Homo ergaster, we're looking at 1.6 million years ago. And with Homo ergaster, you can see, first of all, that this individual was taller than Lucy is. The arms are longer than our arms, but shorter than that of Lucy. And we have this remarkable skeleton, which includes the shape of the femur and the shape of the pelvis. They are more bowl shape, which indicates that this was a bipedal upright organism. And then finally we come here to Neanderthal. Now, this is one reconstruction of Neanderthals. We know tremendous amounts of information about Neanderthal. We have discovered every single bone. The entire genome has been sequenced from Neanderthal. And most recently, they've even sequenced entire Neanderthal families. So we've learned something about the social structure of Neanderthal. Neanderthal is very similar to Homo sapiens. In fact, what we know is that if you have European ancestry, you've got anywhere from 1 to 4% of your DNA comes from Neanderthal. So we have complete fossils, complete skeletal fossils here, but the intermediates between these are known from more partial remains that we'll go through in just a moment.